Good afternoon and welcome to UMass Boston. What a view, what a day. Magnificent. I'm pleased to be here today for our panel on climate science straight talk on the perils of warming oceans. I want to first thank our special guest, Melissa Hoffer, the climate chief in the governor's office of Climate Innovation and Resiliency, as well as all the other panelists joining us today, Professors Bob Chen and Paul Kirshen, climate scientist Susie Mosher, Edwin Somargo, for joining us this afternoon. My thanks to our Provost Berger, for being here as well. And of course, I thank the Governor's Office of Climate Innovation and Resilience for hosting this important event here at UMass Boston. Today, on Earth Day, we are going to consider the profound, far-reaching impacts of warming oceans, a pernicious driver of climate change. They're dire indeed. And in talking straight about warming oceans, we may better understand what it means in people's lives. With unchecked climate change, the very fabric of life on Earth is at risk. We are creating a new and dangerous phase on Earth's history. It refers to the immense effects of human activity on all living systems, all physical systems, including, of course, oceans. We're dangerously warming the planet, in which we are leaving behind the climate in which civilization first emerged. With accelerating climate change, we're at risk of massive failures in crops, new and re-emerging infectious diseases, non-infectious diseases, wildfires, heat, droughts, megastorms, floods, sharply rising sea levels. All of this calls attention to the impacts of the global warming oceans and how it's hastening the loss of marine biodiversity and how it threatens lives and livelihoods of coastal communities, including some 680 million people who live in low-lying coastal areas, nearly 2 billion who live in coastal megacities, and 3.3 billion who depend on fish for protein, and almost 60 million people who work in fisheries and the aquaculture sector. Today, we're going to look at the realities grounded on fact and science, on evidence. In this case, the dynamics of rising ocean temperatures, slower ocean currents, and coastal infrastructure exposure. It is an immense challenge that we face. It's an all-hands-on-deck moment. At UMass Boston, this gorgeous harbor campus in an extremely fragile ecosystem is at the forefront of getting in front the architectures of resilience planning around issues pertinent to the warming of oceans. Our School for the Environment faculty research is generating tools and insights that inform measures on coastal resilience, carbon sequestration, and renewable energy. At our Stone Living Lab, our researchers are deploying blue tech innovation in the form of living seawalls to preserve Boston's coastal environments. At our Urban Harbor Institute, faculty, students are partnering with municipalities and environmental groups to to research issues of concern to our region, like fisheries and access to water resources, with a variety and a view of approaches, new approaches to helping communities in and around Boston plan for resilience. Today is a day for learning about our warming oceans. And it is with that I now have the great honor of introducing our very special guest. Correct me, Chief, if I'm wrong, the only, all of government, climate chief in our country, Melissa Hoffer. Chief.
Thank you. Thank you so much, Chancellor. And thank you, Chancellor Suarez-Orozco, for having us here today for this really important conversation. And I'm so excited to see all of you here today to learn with us about what's happening with the warming of ocean temperatures. Before we get started, I would love it if you would just each briefly take a moment to tell us a little bit about the kind of scientist or expert that you are and what got you personally interested in climate change. We'll just go down the line. If we could start with you, Dr. Sumargo.
Thank you, Chief Hoffer. So my name is Edwin Sumargo. I'm a climate scientist with the Office of Climate Science nested under the Massachusetts Executive Office of Energy and Environmental Affairs. So my role is I'm the team lead as well as responsible for developing this relatively new office, just started last year in July. So really excited to be here and play a role in the state as well. So before that, I was a researcher in the field of hydrometeorology and hydroclimatology. I know that's a mouthful of word, but basically it's how weather and climate affects surface water fluctuations, so including flooding, drought, and so on. So what motivates me to enter the field of climate science? I should say it began when I was little. I was always curious about looking at weather patterns, asking questions, why is the weather here different from there and from different parts of the world? And then I also saw a lot of effects that human activities have done to the environment, including deforestation and air pollution, water pollution, and so on. So with time, I also noticed that how the weather that I felt was, it kept getting warmer with time. And when I asked my parents, who had lived longer, obviously, they also said the same thing. So in high school, I found out about this greenhouse gases, greenhouse effect, and that's how it all got started.
Thank you. Dr. Chen?
Hi, I'm Bob Chen. I'm a professor and interim dean of the School for the Environment here at UMass Boston, the only research university in Massachusetts directly on the ocean. And I teach a large introduction to environmental science class here at UMass Boston, and I tell the students on the first day that every organism living on the surface of the earth is affected by climate change, but only the human species has the ability to choose its relationship with the environment. And so not only does the human species have the ability, but the responsibility to choose its relationship with the environment. So that usually grabs most of the students' attention on the first day.
Thank you. Professor Kirshen?
Sure. My name is Paul Kirshen. I'm a professor in the School of the Environment here at UMass Boston, and also a research director for the Stone Living Lab. My background is actually in civil engineering. As a civil engineer, I know that the built environment is very sensitive to climate. I also know that the human and natural systems are sensitive to climate. So as the climate changes, all the services we get from the built environment, ecosystems, and humans are going to change. And I became very interested in how we're going to adjust to these changes, the process of adaptation.
Thank you. Dr. Moser?
Thanks. Welcome, everyone. My name is Suzanne Moser. I'm an independent researcher and consultant based in Western Massachusetts, so I feel like a foreigner on site. I study human adaptation, the social processes, the governance processes, but I'm also really interested in communication and how science and policy practice can work together. What got me started? It's the first time, the only time in the evolution of this planet that a single species affects the entire Earth system. That's us. And I'm really, really interested why we're doing that and how we're going to direct it in a life-supporting way as opposed to a life-destructive way.
Thank you. So we're going to get started, and I just wanted to direct your attention to the graph over there if you haven't taken a look at it yet. What those lines generally mean is all the little gray lines are sort of, what ocean temperature has looked like over many years. The yellow line is 2023, and as you can see, that line is much higher. So in 2023, we were already seeing sustained high ocean surface temperatures. But what's very alarming is if you can see the red circle around 2024 and the small line just beginning here now in the first quarter of 2024 shows you that we are significantly higher already than even those very high temperatures that we saw in 2023 and 2016. So these are record-breaking temperatures that haven't occurred since humans have lived on the planet. So we're here today to learn more about why that's happening. And as we sit here today, in Earth Week, in Earth Month, Earth Day, I'm thinking a lot about people in Guangdong, China, who are dealing with a flood that is completely unprecedented. That is one of the economic engines of China. Right now, about 100,000 people have had to have been evacuated. It's home to about 127 million people. If you haven't yet, when you leave here, Google it and take a look at it. It's absolutely breathtaking. And then if you think, at the same time in India, we have people suffering under an unprecedented heat, 115 degrees Fahrenheit. So this is really what's happening right now on the planet. We're going to learn today a little bit about how that's related to ocean temperature warming. So Bob, I've been reading a lot about this topic, how hot the oceans are right now. It's not something that's received a lot of coverage in the news. And so it's not something that many people might even understand is happening. So that's our job today, is to kind of let folks know what's going on and why. So could you explain to us what's happening right now and kind of what are the mechanics of how climate change is causing oceans to warm?
Well, let me say that, for hundreds or thousands of years, the ocean temperatures have been relatively stable. They change from hour to hour and day to day and season to season and from place to place. But it's sort of like, a human body temperature, right? 98.6 is the common standard equilibrium temperature. And 98.5, 98.7, not a big deal. Like, you don't call the doctor. But 99.5, 100 degrees, you begin to say something's systemically wrong with the system, right? And so what has happened? Well, since the Industrial Revolution, we've taken carbon that has been buried for millions of years deep in the earth, away from the atmosphere, burned it to carbon dioxide in the atmosphere. And CO2 in the atmosphere creates a heat-trapping blanket. It actually traps the energy that comes in from the sun at the surface of the earth and warms the surface of the earth. And the more CO2 in the atmosphere, the thicker the blanket and the warmer that we get. So that's what's sort of happening. There's some tweaks to it in that, for example, the Arctic is warming faster and helping the Earth warm faster than it has before because the white snow and ice reflects a lot of that energy and cools the planet and the Arctic. But as you melt the ice, it turns to dark blue ocean, which absorbs more energy. So now we're absorbing more energy than we have sort of over time. So that's accelerated the pace of warming. And the air goes up and down faster than the ocean. The ocean absorbs that heat and stays warm for longer. Last year they got over 100-degree ocean temperatures off Florida. That is the temperature of a hot tub. And a hot tub that we go in for 10 or 20 minutes to get warm on a cold winter day, but we can get warm, we can cool off after the hot tub. We evaporate the water. If we are not in a hot tub and we're sweating, we can cool off. We can go in the shade. We can go in air conditioning. We have ways to adapt to that. But if you're a fish in Florida or a mussel or an oyster, there's no escaping that heat. And that is really symptomatic of something wrong with the system. It's very hard to survive.
Thank you. So, Edwin, maybe for you, for this one, we just heard a little bit from Bob about the drivers, what's actually causing that buildup of greenhouse gases. Could you tell us a little bit more about, even just what's happening on a daily basis that's causing this buildup of the greenhouse gases to occur?
Yeah, so basically this greenhouse gases is a product when we are burning fossil fuels. So whether it is at industrial scales or whether it is something that we do on a day-by-day basis, for example, when we are running our car, driving our car, and also when we are running our household appliances, or also let's say, like the heating equipment as well, where it is running from, let's say, the oil or gas. That is how we emit these greenhouse gases. So as Bob mentioned, also I want to reinforce that when we are burning this burning these fossil fuels and producing these greenhouse gases, as it is released to the atmosphere, it is like we are adding more and more layers of blankets. So again, not to speak too much, but then it's like when you are in the winter, the cold winter night, you are putting on your blanket, it's nice, but then you keep adding more blanket, another one, until eventually you feel like it's really hot. It's not because, unless you have an electric blanket, the blanket doesn't emit the heat itself, but then it's trapping your body heat, so it works like that.
That is a great way to understand it. That's very helpful. So, even just thinking about this, kind of gradual warming that's happening over time with greenhouse gases being emitted at such intensity throughout the Industrial Revolution, this is a pretty big jump in temperatures, even above, what we've seen in recent years. So, Bob, I want to come back to you. Scientists seem to be kind of confused. Why are the oceans so warm, so much warmer in such a short period of time? Why is that happening?
Well, I'll say there's a lot of different complexities to the individual day or week or year of temperature, but it's really not surprising to me. The average here for 30 years is here. The last decade is up here. So of course we're going to have record-setting temperatures at some year in there, and there's going to be some part of the system that Edwin can explain that is different from year to year. So surprising that 2023 is a record-breaking year. It's going to happen, but the baseline's changing. It's going to happen again, and maybe this year, 2024, is already the next record-breaking year.
Wow, so that is really something for everybody
Unfortunately, not surprising.
Absorb. Unfortunately, not surprising. Edwin, I know you have given some thought to some of the other theories that might be out there about why we're seeing this accelerated ocean warming. Do you want to help us understand some of those?
Yeah, so for one thing, I have to acknowledge that you probably have picked up from the news, it is strong El Nino year and what might happen to the weather and so on back in fall. And definitely I cannot deny, I have to number crunch myself to really know for sure what percentage is by El Nino and so on. But then now, even if it is strong El Nino, it still doesn't explain why we have keep having this record-breaking ocean warming or even record-breaking heat that we have here, and record-breaking the global average temperature that we are seeing right now. So that's one explanation. And then another part also that I don't know again to which percentage this contributes to this, but then we have to remember back in the 20th century, we, in the middle of the 20th century, we released a lot of emissions, including the aerosols, for example, like sulfur aerosols, nitrous oxides, and so on, before or until when the government enacted Clean Air Act. So why am I mentioning this? First of all, because first, ocean has absorbed most of the heat that is coming into the globe. And then eventually it will release back into the atmosphere, right? And the signal that we are seeing, supposedly, if we want to see it right away, and it's supposed to keep increasing with the amount of greenhouse gases that we are seeing. But then, early on, what I said about these aerosols, it is acting like a mask that tempered down the warming that it should have happened. So. My sense is that partially what we are seeing now is slowly unfolding the effect of unmasking these aerosol effects into the warming that we are seeing right now. And again, of course, to reinforce what Bob said, with the non-linearity in the system, it is a complex system. We don't have time to explain everything. But then what I'm going to say is that it is not necessarily linear in the sense where this year we are going to be 1 degree warmer, next year another degree, and then the year following another degree again. So there's going to be back and forth, as we can see from those charts, right? I don't know, I'm just making things up. Maybe next year it is going to not be, it's not going to be as warm as this year, but then if we look at over the scale of a decade and more and more we will see this increasing trend, and then once in a while we will get a bump like last year and then again this year.
So the general trend is for more warming, much warmer oceans with all the impacts that you're talking about. The causes are combustion of fossil fuels primarily, but also large-scale deforestation, as you're telling us, and that, ironically, some of our effort to clean up other kinds of pollution is actually potentially magnifying the warming. So this is a very helpful way to explain it for us. So, Paul, I'm going to move it over to you for a minute. I think if we walked over there now and we dipped our toe in the ocean, it would still be pretty cold. So why are scientists so alarmed about this? Why does it matter if it's just a couple of degrees?
Yeah, sure. First of all, the warming is all relative, right? And it's just indicative of this new climate we're in. So I want to talk a little bit about this new climate we're in, and talk about some of the impacts of this new climate. So in the old climate, sea level rise in Boston was about a foot lower. The sea levels were about a foot lower. In this new climate, in the old climate, we had about 10 days a year when the maximum temperature was above 90 degrees Fahrenheit. In our new climate today, we have about 15 days where the temperature is above 90 degrees Fahrenheit. By the end of the century, we could have 30 to 90 days where the maximum temperature is greater than 90 degrees Fahrenheit.
And that's right here in Boston?
Yes, in Boston. So that means like perhaps every day of the summer might be over 90 degrees Fahrenheit. Then also in terms of extreme rainfall, in the old climate, an extreme rainfall event had like 4 inches of rain in 24 hours. Now it's about 5 inches in 24 hours. In the future, it could be 6 or 7 inches in 24 hours. So we have this new climate here. And some of the impacts of that. Well, the warming ocean is resulting in thermal expansion of the ocean. So it's making the ocean get higher, increasing sea levels. Also, the warmer air temperature is melting a lot of the ice on land, our glaciers, our polar ice caps, the ice sheets in Greenland. These are all flowing into the ocean, also increasing sea level rise. So with increased sea level rise, we have a couple of impacts. One is our high tides are higher. We also have more erosion. So that results in more sunny day flooding in like Morrissey Boulevard right out here, in Liberty Plaza in East Boston, in Long Wharf in Boston. Also, the increased erosion is impacting our beaches. It was responsible for one house in Nantucket being sold for $600,000 on the coast because it's losing its land. It's going to have no value, perhaps in a decade or less. Also, the rising tides are impacting our ecosystems. For example, I just read this the other day, something like 98% of our wetlands could become tidal flats by the end of the century. And our marshes are incredibly important parts of our ecosystems. So to think that they all could be gone by the end of the century is truly frightening. Another impact is on cold water fisheries. We used to have a lot of lobster and cod south of Cape Cod, but now the fact the water there is so warm, it's really not good for those species. So now we really only find those species north of the Cape. And then, of course, higher sea levels also result in our coastal storms coming in higher. So, when we get a coastal storm now, like we had a couple of years ago, it doesn't cause too much damage. But let's say by 2070 or so, the average damage to buildings in Boston from a coastal storm could be like $1.4 billion. Okay, that's the average damage. So some years it's going to be more, some years it's going to be less. But that's a large number, $1.4 billion. Those are some of the coastal impacts. The other thing I want to point out is with the oceans being warmer, we're having more evaporation. And with more evaporation comes more precipitation. And so with more extreme rainfall and this general intensification of the hydrologic cycle, we're going to have more extreme rainfall events. I already mentioned that, the amount of rain in a storm has increased. Well, some of the recent evidence of this was in, I think last fall, we had really bad flooding in Leominster, Mass. It caused like $36 million worth of damage. In July and September of 2022, we had really bad flooding of farms in western Massachusetts. Again, these events can become more commonplace because of the climate change that we've caused.
Thanks, Paul. I mean, you're really helping us understand that what happens with ocean temperatures really affects the whole state of Massachusetts. I wanted to just follow up on your point about the economic impact, because there's a study that just came out in Nature last week, which is estimating $38 trillion in damages every year up through 2050. So the headline was, "The World Economy Already Committed to Income Reduction of 19%. So overall, the article is essentially saying that there are global damages estimated to be at $38 trillion with a likely range of $19 to $59 trillion by 2050. And that's for what's locked in now, even regardless of what we do. So when you hear a number like that, and I know you've thought about insurance industry and real estate markets and financial systems and the like, how does it affect people's lives here? I mean, what does it do to stuff like food production or public health?
Sure. Well, just talk about insurance, okay? Insurance rates in Massachusetts are going up about 15% this year because of climate change and inflation. And also, it's very difficult to buy private wind insurance now along the coast because the insurance companies, the market, are realizing how dangerous it is to live along the coast. But as the chief pointed out, these impacts also have some indirect consequences. For example, if our harbors get impacted, it impacts all the supply lines. What happens in Mississippi, what happens to Boston, impacts what happens in the interior of the country. Also, we have all these health consequences. We're going to have more vector-borne diseases, more heat stress. I understand right now we have about 15 deaths a year in Massachusetts from heat stress. By the end of the century, it could be 400 deaths a year from heat stress. So there are all these consequences. And of course, I'm not even talking about the impacts on biodiversity. And we are so dependent on our ecosystems. And if they go, which we seem to be going in that direction, it's going to, impact them, but it's also going to impact us. Because we're so, I know in terms of engineering, we are so dependent on ecosystems to provide services like water purification, flood management, recreation. Also, nature is a huge spiritual resource to us. So there are all these cascading things we have to worry about in terms of climate change. That's why it's really important we try to get to net zero emission as soon as we can.
Thank you. Bob, you have talked a little bit as we were preparing for this about some of the other things that are happening to the ocean that are related to climate change. And you've spoken about ocean acidification, and you've also talked about the coral bleaching that's happening as a result of these high temperatures. So I don't know if you just explain what coral bleaching is and what ocean acidification is and what the impacts are on ocean life.
So we've been talking about temperatures, but I'm a chemical oceanographer and studying carbon cycling on Earth. And so I study where carbon goes. And if you put more CO2 in the atmosphere, it forces more carbon dioxide gas into the ocean. It's just like forcing the bubbles into Coke. And when you do that, the CO2 combines with water to make carbonic acid. That's an acid. It lowers the pH and makes the ocean acid. And when you're living in the ocean, like living as humans, we are affected by multiple stressors. And there's a study that says Division I athletes get injured twice as often during midterms than other times of the semester. So if your mental health is hurting, your physical health is more at risk. And so if you are affected by ocean acidification and the ocean's warmer and there's less food, you're going to be affected by things. And so organisms that live in the ocean like this is a cowrie from Hawaii. It's a beautiful shell that lives on the reef. And I don't know what's over here, a clamshell from Boston Harbor. These are calcium carbonate-bearing shells that take energy to make their homes. And if it takes more energy to make their home in an acidifying ocean, it becomes more stressful for them to survive and live. Now, corals are very, very beautiful animals that create these reefs that are recreational and tourism hotspots of the world, but also biodiversity hotspots and locations for huge amounts of fisheries. But what happens when the coral animal gets stressed, they're gardeners. So they actually have algae that they put in their coral skeletons, and they grow it for food, and creates all the colors, the beautiful, vibrant colors that we see of coral reefs that we like to go scuba diving on and snorkeling and whatnot. And when it gets really hot and the pH goes down and gets acid, they can't have enough energy to keep their garden going, and so they release all these algae into the water, and the corals go stark white. And that's coral bleaching, and it's happening across more than half of the coral reefs of the world's oceans, year after year after year. And it's estimated that the coral reefs are pretty much could be going away by 2050.
Why do coral reefs matter to people in this room?
Just if you eat seafood, a lot of the seafood comes from the places with reefs and where the nurseries are for reefs. If you ever have seen a pretty picture of a coral reef and some of these tropical places, you might want to go there. But even if you don't go there, that idea of that area is again something that we like to think about, and that will go away.
Yeah.
So economically, billions of people make their livings on the reefs. So many people and so much economics is dependent on coral reefs, and with the bleaching and their sort of survivor at question, it's really a problem.
So again, something that really has multiple different kinds of impacts and touches us here. Susie, I'm going to turn it to you. You're an expert on adaptation, and you study, in part, a lot of the ways that these climate impacts are interrelated, and also how communities can become more resilient. So we've just heard a lot about what's going on, what the impacts are, all the different kinds. And I'm wondering if you could give us a little bit of a synthesis about what this big picture of ocean warming means, these climate impacts, and what are the implications for mitigation and adaptation and resilience. And if you're somebody that's new to the conversation about climate, could you maybe just start us off explaining what the difference is between mitigation, adaptation, and resilience?
Yeah, thanks for that question, really important. So let me just first acknowledge what we just heard, this litany of doom. It's just hard, and I just want to collectively invite us to take a deep breath, because it just actually is not just for you listening, but for the scientists studying this on a daily basis. It's actually pretty hard to look the apocalypse in the eye, and you all working on this or just entering in this field, I think you all experience that too on a daily basis. So I want to just acknowledge that. The second thing that I hear listening to each of you is, I guess the way I would sum it up is what happens in the ocean doesn't stay in the ocean. It's like, yes, it does cause damage to the critters and the seafood and the livelihoods that depend on the seafood and the protection we get from coral reefs, whatever. That happens definitely in the oceans. But coastal communities, what Paul mentioned, with sea level rise, more erosion, more flooding, that's actually, that's where most of humanity lives, in coastal areas. That's important to remember. They have to go somewhere. So more sunny day flooding, more inundation, more coastal storm damage. That will impact all of us. The insurance industries, everything that protects us, the economy that is situated in coastal areas. And then, even the impacts further inland, right? I mean, if the oceans, which cover 2/3 of the planet, are the engine, if you will, of our climate, it affects everything, everywhere. No one is safe from a destabilized ocean. So that would be maybe the way to summarize it. So you asked me to define some of these terms. So to me, the way I like to think about it is the responses we have to climate change, it's like not only requires all hands on deck, but it's like you can wrap your arms around it. On the front end of the problem, mitigation, we try to reduce the causes. We try to not make this problem any worse, right? So reducing the emissions to the atmosphere so that we don't add further blankets to the heat-trapping atmosphere. On the back end of the problem, we have to deal with, you just said it, we're locked into $37 trillion of damage no matter what we do. We have to prepare for that. How do we deal with that? The level of impacts that we just talked about, right? So mitigation on the front end, adaptation on the back end. And why? Because we want to keep going in the face of change. And that, to me, is the best definition of resilience, right? So even when things get disrupted, you can get back up on your feet and you can, come back and I would say come back better. And maybe the last comment I would say, just by way of introduction, is that across all of that, each one of these options, it must be, at the center of it, must be social justice and equity. Because the crux of the matter is that the people who are least responsible for this issue are actually suffering the most from it. I mean, if that's not the definition of injustice, I don't know what is, right? So we have to put our hands on giving people jobs who could be in the clean economy, the green economy, clean energy economy. We have to help them get out of places that are really unsafe and help them, build back better if they get disrupted by a disaster. So to me, that must be at the center of it, or else we're going to be just failing massive amounts of people, both here in this state, but globally.
So I know we want to get to your questions. I'm going to just go through one final question for all of you. And this is a big question, so maybe just, pick your very top response to it. But, thinking about what we've heard, is there anything that we can do, the people in this room, is there anything that we can do today to stop the warming of the oceans and to stop the progress of climate change? What's the most important thing when you think about it that you think that we can do? And Edwin, I'm going to start with you.
Yeah, I think that there are many things that we can do both individually and also collectively. If I want to start, of course, that as a society and our whole economy, for example, we want to remember that how this all started. It's our emissions, greenhouse gas emissions from burning fossil fuels. So we have to deal with that. And one example is decarbonizing our economy and our infrastructure and technology and so on. So on individual levels, there are many things. There are too many things that I can say about that. For one thing, if I want to put on my hat as a state climate scientist, we have already put out some of the guidelines that individuals, average citizens can take a look at when you want some tips about what you can do day-by-day basis. So on personal tips, there are many fancy things and grand things you can do. All of those are good. But then we also have to remember that there are some simple things that seemingly simple and small, but then if we keep doing that and then all of us individually keep doing that, it will add up. So for example, whenever possible and available, instead of driving your car to work or school, you can take the train or the bus and public transport and so on.
Thank you. And you said something so beautiful in our preparation to this that I'm just going to repeat it. But Edwin was talking about how, we were all thinking about bending the curve during COVID, and that it was so important for us to just try to reduce further transmission of COVID. And so he was thinking about it in terms of this is what we're doing now. We're bending the curve on emissions. And if we can really focus on some of the more powerful emissions like methane or some of the other pollutants that are even more powerful than greenhouse gases, that's a great way to go. Natural gas, I think you probably all know this, maybe some of you could teach it, is methane. So that was just a beautiful way to say it. How about you, Bob?
There's a lot of systems in the world that are broken today. We've got transportation and housing, we've got wealth inequality, we have racial injustice, and I'm really excited about the opportunities of disruption for the green transition. I come back to the students that I teach. I say, the opportunities for a new, creative, innovative job, a career in addressing all of these problems in a win-win-win solution this is the exciting time of our moment right here. And so talk about it. Think about how whatever career path you're doing and whatever job that you're thinking about, how this fixes multiple of these issues. We are going to transition off of fossil fuels, and it's just a matter of how fast and how much money we can save and how we can get these really interesting jobs. It's an all-hands-on-deck moment. We need everyone's perspective and background and lived experience to solve multiple problems.
Fantastic. Thank you. How about you, Paul?
Sure. I think, the small steps we can take as individuals are very important, like driving less, eating less meat, things like that. But we also need really large steps. We need to move quickly towards renewable energy, more wind, more solar, more green hydrogen. We need to operate our infrastructure better. What's frustrating to me is, technologically, we know how to get to net zero emission in a couple of decades. We know how to protect our coastline, and that's not happening for a bunch of reasons. So I think, we've also got to have we also have to vote correctly to get the right people in there to lead us, not just only in Massachusetts, where we have great leadership, but also throughout the rest of the country and the rest of the world.
I love that, Paul. I really like your focus on collective action. I think that's so, so important. There's definitely an individual piece, but I really appreciate that point. Susie.
I guess I'm going to make that even more practical than what Paul just said. How many of you are registered to vote? Woo! Okay, if you're not yet registered to vote, that would be their next step, moving out of this room. So, and if you're not voting in Massachusetts and you're having some home state that may be tipping one way or the other, that might make a big difference. So anyway, that's very concrete, one thing you can do. And I guess I would also say, don't do it alone, right? Take 2 friends to go vote. Or, if you're living in a communal living situation, talk with each other about how can we lower the footprint that we have in our household. Can we get this together? Everything matters. So that would be my answer right now.
Thank you. And Chancellor, whose climate leadership inspires me, what would you say?
Thank you so much. And reflecting upon Susie's, I think, sober frame, what does it look like looking into the apocalypse? My main humble contribution here would be education and climate literacy. I would be remiss if I didn't articulate that claim. Young people are hunger for concrete, science-informed responses to adapt, to move us away from what is, let's be clear, an unsustainable humanity. This pathway doesn't work. We need to engineer a new pathway. And I believe that education is fundamental. Looking in another time of great darkness, one of the greatest novelists of the 20th century, who went on to win the Nobel Prize in Literature, an Algerian expat in Paris, Albert Camus, wrote beautifully, "Where there is no hope, we need to invent it." This is the task today. And education is the most powerful invention of our neocortex to get in front of an unsustainable humanity, to take us into a new path to greater sustainability, equality, justice. That's why we're gathering mayors and governors from around the world. That's why we're gathering the leading, some of the leading scientists and social scientists, some in this room, soon in Rome, to articulate the claim for moving to what I'd like to call MAST, M-A-S-T, for mass, M-A-S-S. Mitigation. Susie explained to us what that looks like. Adaptation. This is in the here and now what we need to do to prepare to continue to absorb the shocks and check climate change will continue to generate over the next 2 generations. We're going to get to the point of decarbonating the economy and society. I'm certain of that. The gap is too great. In the meantime, what's unfolding in coastal China today is a story that will repeat itself around the world. So it's massed mitigation, adaptation, societal transformation into a sustainable humanity, a humanity based on justice, based on protecting the limited resources that live in nature. Thank you.
Thank you so much, Chancellor. That call for hope and for courage, if I may, and for imagination. What would the world look like if we actually lived with this knowledge in mind and close to our hearts. So with that, we'd love to have some questions from all of you, and just maybe raise your hand if you have a question for anyone on the panel.
Thank you. I was on Nantucket for a School for the Environment field trip with Beth Boyle, and I saw a lot of the houses are very close to the edge, collapsing into the sea. Do you guys believe that it is more likely that they will just continue to move inland on the island, or do you believe the island will become abandoned if sea levels continue to rise?
Paul, do you want to take that one?
Sure. I guess the question was, what's going to happen to these coastal homes, right? So,
Thank you.
two things, right? They're either going to collapse into the sea. There's three things. They collapse into the sea. They're somehow going to fortify themselves, like they're going to elevate them, or they're going to retreat in a managed way and move back from the coast. And they're probably not going to move the homes, but the people are going to move inland. And those are sort of the options we have. And what's going to happen, we don't know. There's some indication that there is movement towards managed retreat now. People are starting to move away from the coast. And I think that's probably going to continue as the coastline becomes more and more dangerous to live at.
Susie, I know you've given some thought to how communities make these decisions.
Yeah.
These are tough decisions. You've grown up in a place, you know that place, you love it. How do people approach that?
Yeah, it's, it is very much the menu that Paul laid out. But you have to sort of think that forward, right? Think about how many times are you willing to accept coastal flooding? How, safe do you personally feel when, more and more of the cliff in front of your front door is moving, is being eroded away, right? So there are personal decisions. There are also community-supported plans where they basically say, at some point we just decide we're going to move houses backwards. There are programs that can help that. New Jersey has a beautiful program that helps individual homeowners who make that choice to basically buy them out, demolish the building, and help them find a different place to live. We can't just think about removing the individual structures and then sort of like throwing up the hands in the air and just say good luck. We actually have to help people find new places, and all the discussion in the newspaper here about housing crisis and affordable housing. A lot of affordable housing is in floodplains, just want to say, right? I mean, there's just really dumb things we have done over time. So there's a lot of things that we have to think about at the same time. But actually just telling people, you can't live here anymore, that has tended to lead to a lot of resistance and opposition, and that's not the best way to approach that. So a really comprehensive and detailed hand-holding, I want to say, and community engagement around, collectively making the decisions. When are we leaving? When is this neighborhood ready to, en masse, if you will, move to a safer place? That's really important. Whether or not Nantucket is going to be eroded away entirely, that's going to be a while, I think, not in our lifetimes. And we have to figure out what are we going to do with the people who sit right on the edge.
I'll just add, the island will be fine. It erodes on one side and it accretes on the other, but it migrates. The problem is the mismatch between the social systems and the human systems and the natural systems. We have a property boundary. We can't go beyond that. We have a house that's either there or it's not, and it's not a few dollars to move it a foot per year. It's you got to pick it up and move the whole thing and rebuild, or it collapses into the ocean. So there's a mismatch. Nature knows how to adapt. Humans have some structures in place that don't allow us to adapt.
Well,
No.
they don't, sorry for interrupting, they don't allow us right now. But, one of the big challenges I think that we're having in front of us is that we actually have designed systems for stability, and our grand task in adaptation as a society is that we design systems for change now. And it's a very different idea, right? How do we design finance systems that support people to move? How do we shift boundaries? How do we get people to actually like living next to each other a little more densely? I mean, there's like a ton of issues, right? And the infrastructure that has to go with it. So essentially is we have to think outside the conventional systems of how we govern ourselves so that we help people make those moves.
Thank you. Other questions?
Go for it.
Also in Nantucket, I saw geotubes, I think they're called, which are massive sandbanks inside of massive bags that they placed in order to prevent erosion. What are your opinions on this method?
Does anyone have a view on geotubes?
No, it's very much of a temporary measure, and that's how we can only look at it. And I think they're now no longer allowing them, which is probably the right decision, though it's very controversial. It was just a temporary measure.
Can somebody explain what they are, so for people
Yeah.
who might not understand?
Yeah, they're giant sandbags, like really giant sandbags that are put right on the, on the edge of the ocean to basically slow down the erosive process. I have seen geotubes in every shape and form, including what they look like after a few more storms have gone down on them. It's basically a lot more plastic waste in the ocean, is what I want to say. So at best, what I would say is it can buy you time. And, because we're not used to making those changes, we need time. So I would say for that, it's a, somewhat limited but okay temporary solution. And if we think that that's the end point, then we just misuse them. We really need to use that time to figure out how we're going to move people back, how we're going to transfer their right to their property, all of that stuff, right? So it's a challenging thing. As is always the case with hard structures, they enhance the erosion actually, on the left and the right to those structures. So geotubes do that too, just like, riprap or seawalls do. So it's not a solution. It actually just buys us time.
So we're all learning here today. Good. We got time for one or two more. Don't be shy.
Thanks. Hi, this has been really interesting. Is this on? Can you guys hear? So my question is about the mismatch between, it sounds like we know a lot about what's happening with the ocean and ocean temperatures, and I know there's more uncertainty as you move out, but we certainly know what might happen in the next 5 to 10 years, right? But there seems like there's a delay in action, both individual action on behalf, or on the part of industry, action from governments. What do you attribute that mismatch to, other than finances, perhaps, and reelectability? And have you seen any places where people are getting it right? Like people are acting on data in a way that quickly responds in terms of policy or economy?
It's a great question. Anyone want to dive in?
I'm
Go ahead,
happy to
Susie.
take a start. So, what you just said, besides the finances or the financial interests and electability, those are important considerations in a democracy, and in one where money plays as big a role as it does. So we've had 40 years of campaigns against people trying to take this problem as seriously as it is, and it's actually worked for the most part. So I just want to say that that's not an aside. That's actually a central point to this. And humans don't particularly like changing. I mean, have you made any big changes, really big changes, like several times last week? No, we don't do that, right? None of us like to do that. And as I said before, we invest into things for stability, right? For things to stay the same. So there aren't quick fixes to, let's just move this road over, or let's just move these people over here. That doesn't work like that. So I think that's a big part of it. The fact that, I used to say we lived on the luxury end of the exponential curves. I mean, you've all seen these projections that sort of have that shape, right? Getting steeper and steeper. And in the beginning, the change was like so small that you say, well, that's just like another, slightly off year. It's not a big thing. Well, we have now moved, I think, here into the part of the curve where it gets steeper and steeper every time, right? Exponential curves are not our friends. And so I think you're going to see a lot more responses to more and more disasters. And it's incredibly difficult at this point to you can't just turn it off. There is so much baked into the oceans. There is so much baked into the atmosphere. Even if we could stop emissions immediately, we would still see decades, and as far as sea level rise is concerned, centuries of continued change, right? So it's actually really, really hard to get processes set in motion that take us off of this particular destructive path and onto, as you suggested, a more transformative path toward justice, toward, sustainability. So I think there are examples, and we can maybe talk more about, maybe others have examples of that.
I'll add this, evolve for stability and being reactive rather than proactive. But one, I think there's hope in youth. Youth are unconstrained by a lot of the things that built in this stability and are really willing to change as they grow their thinking about the world very quickly. And the others that there are communities, the indigenous communities, that think over longer timescales. And a couple of them on the West Coast have thought about what is important to them, keeping the community together, and they know that the ocean is rising, so they proactively moved inland and upland ahead 10, 20, 50, 2 years ahead of the sea. They know it's coming. We sort of know, scientists know it's coming. We think we know it's coming, but you don't really believe it until we have to react. But proactively thinking over longer timescales can really save you a lot of headache.
I'm going to exercise my prerogative as moderator and just respond myself briefly to that, having litigated for a number of years against ExxonMobil Corporation. You can read our complaint. It's an 800-paragraph complaint that resides on the website of the Attorney General's office. And you can learn a little bit about the history of deceit. I also recommend, if anybody's really interested in this, Naomi Oreskes' book. She's a historian of science at Harvard University called Merchants of Doubt. And it will show you how the fossil fuel industry used the playbook from the tobacco industry to sow doubt about whether climate change was actually occurring for over 4 decades. So that's one of the reasons why we're so behind the power curve. And I want to leave us on a positive note, which is some of the work that's been done by the Biden administration, by the Healy administration, by Governor Newsom out in California. We now have the Inflation Reduction Act, which for every dollar the United States, that's our money, is putting into clean energy future is now leveraging $6 from private industry, and it's going into all kinds of technology to help us reduce greenhouse gas emissions. So that's huge and really important. We have the Mass Leads Act. Please come out and support that. That's Governor Healy's moonshot around climate change, which it's proposing to invest $1.3 billion into climate tech here in Massachusetts. So that's not only good paying jobs for people in all kinds of areas, and really, really cool stuff. We're not just talking about solar and wind or the things you might know, which are super, super important, but also some of the really cutting edge stuff, anything climate tech. This could be alternative proteins. It can be plant genetic engineering to be more, resistant to the impacts of climate change. So very, very exciting stuff happening there. And we see governments changing, and we're talking about this incredible, incredible summit that your chancellor has been so intimately involved in. That really gives us a chance to think with other governors and mayors around the world about how governance structures need to change. And that's a very important thing too, because when you think about our institutions are really designed to create the conditions that create climate change, right? It's just what we do every day. So as we're shifting our clean energy and we are shifting how we are organizing ourselves socially, that social transformation that your chancellor talked about, that's really important. And we do that by changing how our institutions work, what the goals are, and how we get there. And you all play a huge role in that. So I just want to thank everybody for coming out today. I know you have busy class schedules, but it was great to see you all here, and we're very grateful for your interest. And I really want to thank everybody on the panel today for bringing everything that you do every day to help people understand these issues better, and for your leadership, and of course to you, Chancellor. Thank you so much.